Okay, for example 3, Mr. Lee wants to park his ice cream cart on Main Street so that he's equidistant from the entrances of the amusement park and the zoo. And how can he determine where to park? So, he's parking on Main Street, the zoo entrance and the park entrance. Let's just say that there's a point here and a point here that represents the entrances. Okay, so this is me just playing with a map right now. So, you go to Google Maps, print out some map, you can put points on the map and then start using your compass and straight edge in order to do some geometry to it. Right? So we're trying to find out the spot along Main Street where we should park. And what I want you to recognize here is that the zoo entrance and park entrance represent endpoints of a segment if we were to draw a segment to connect those. So the first thing I would probably do is go ahead and draw a segment to represent the distance between the zoo and the park entrance. Okay. And let's just call this point Z. We can call this point P. You give them names. Okay, he wants to be the same distance from the entrances, so he wants to be the same distance from these two endpoints. So what we just established is if we can draw a perpendicular bisector through PZ, then every point on that bisector is the same distance from the endpoints, right? So in essence, what I need to do here now is to construct a perpendicular bisector to PZ. And we did this back in chapter 1, which was a long time ago. So we'll remind you how to do that real quick. Okay, the first thing you're going to do is you're going to take your compass and you're going to position it on the, I'm going to do this. I got to be careful with mine because I don't have, position your compass on either P or Z, doesn't matter which one. Okay, and then open your compass beyond halfway. You can kind of ballpark where halfway is, go past that point. It doesn't matter exactly how far, just go beyond halfway. And you want to construct an arc both above and below your segment. So I'm going to put an arc down here that goes beyond the halfway point. So again, I'm ballparking halfway is kind of in here. So I'm going to make sure my arc goes beyond that. And then I'm going to go up here and do the same thing, construct an arc above. Okay. Recall that as I made that compass opening, that I did not care how wide open it was, just as long as it's more than halfway. Okay. Now carefully pick your compass up and then slide it over to Z. Do not change the compass setting. So again, it didn't matter how wide open it was, but once you make that decision, that's how wide open it is. Don't change your mind. And now you're going to, from Z, make a couple arcs also that should intersect the arcs you just made. So there's an arc, and there's an arc. It makes these fancy curvy X's. Right, that's what we're looking at here. What we've done there is we measured off two, basically, if you imagine a compass draws a circle, right? So imagine a whole circle happening here and a whole circle happening there, right? You got to construct two circles with the same radius. So the distance from P to here and from Z to there are the same. And that's what we're looking to make happen, right? We want those distances to be the same. So now if I were to get my straight edge out and position it so it lines up on those points, the points I just created, like so. And then connect the dots with a straight line using my straight edge, like so. That line is the perpendicular bisector of PZ. Okay. And the question is, where should Mr. Lee park his truck or his cart? So right here along Main Street, point C is where Mr. Lee should park his ice cream cart. maybe a step or two off the highway, right? But the idea is that we just construct a perpendicular bisector, and the perpendicular bisector theorem says, if you have a perpendicular bisector to a segment, then any point on that bisector is the same distance to the endpoints of the segment. So that's ice cream cart, if he parks it right there, will be equidistant from the park on the zoo entrances.